As mentioned before, pure functions are the foundation of functional programming. When following the functional paradigm, we strive to make as many of our functions pure as possible. So we need to understand what a pure function is. So to be a pure function, it must satisfy two conditions. First, given the same arguments, so if we pass in the same arguments to the function, it always calculates and returns the same results. That's the first thing. The second condition it must satisfy is when calculating the results, when the function is doing whatever it does not cause any side effects. Now, what do we mean by side effects? Well, we'll get into that as we look at some examples. But basically, pure functions don't depend upon or modify anything outside the function scope and always returns the same results whenever the same input is supplied. So let's take a look at those examples I talked about. All right, first I'm going to set up a function here, and I'm going to have it use a global variable here. We're just creating a global num, and I'm setting it to 9 is all I'm doing. Now here is the function. This function is just going to create a new number. We're going to pass in a number like that, and then the number it returns is going to be the number that's passed in multiplied by the global number, okay? So that's all it's doing. All right, so let me go ahead and save that, and let's take a look at a few things here with this simple function that we've created. So if I go to the console, and if I go ahead and invoke that function, new num, and I'm going to pass in a 5 for this, and I invoke that function, pass in a 5, we get 45 in return. Now if I continue to do this, we continue to get 45. So it seems to meet that criteria. However, what would happen if we change global num to a 10? Now, if I call that again, now we're getting something different. So it's the same input, but we're getting a different output, all right? And in this case, the reason for that is because it's relying on something that's outside the function, which is a problem. Now, let's take a look at an example that illustrates side effects. So I'm going to create a new function here. Let's see, we'll call this one, let's call it new num2. Being really creative with the names right now. Okay, and this one receives a number as well, but it does a little bit more. We're going to see if we can't resolve this issue, okay? So what I'm going to do here is I'm going to create an if statement. And I'm going to check the global num. And if it's not equal to 9, then what am I going to do? Well, I'm going to set it to 9, all right? Now, this is an example of side effects. We are doing something inside this function that is affecting something outside of it. That is a side effect, all right? But it looks like it solves our problem here of the global num being changed. If it changes, it's going to use 9 anyway. So let's go ahead and finish setting this up. It's going to return the number times global num, all right? Now, once again, we can go ahead and invoke that multiple times. This time it's new num2, and I'm going to pass in the 5 just like we were doing before. And so we're getting 45. If we do it again, we get 45. We continue to get 45. Now, if I change the global number, well, the global number is already changed. It's showing out here. But if I change it to something else, 9, which is what we want it to be, we continue to get that same result. So the result's not going to change here. But now we have a side effect. So think about this for a minute. If something else, just like our first function here, if something else is relying on this number and we change it within the function, well, it's going to break something else, something that we are not anticipating. And that's the reason we don't like side effects. That's the reason that pure functions need to not have side effects. And we also need to make sure that pure functions always return the same results if we pass in the same data. We can rely on them. That is the advantage of pure functions. Okay, so that is a side effect, what we've given there. Now let me show you another common side effect that we sometimes run into. And this has to do with changing of arguments, okay? So I'm going to set up an array here. We're going to use this array in this next function. It's just an array of scores. Let me just enter a few scores in here. 70, we'll do one more. And put our semicolon there. So there is our array. Now, I'm going to create a function here. Basically what it's going to do is just remove the last score from the array. So it's a pretty simple function. It's going to receive an array. And then what is it going to do? Well, whoops. It's going to return that array after we've popped off a value. So it's going to remove that last value, okay? And so let me set up a variable here, last score. I'm going to set up last score, and I'm going to call remove last score. And then I'm going to pass in the scores array. And so what we should get here is a 60. All right, so let's go ahead and take a look at that. So if we look at our last score, we do get a 60. Now the side effect that I want to point out is, let's take a look at the scores array. Notice the scores array has now been changed. It no longer has 4 items in it. It removed that last item and affected that, okay? So that is a side effect. If something else is using that array, or if we pass that array into another function, it's changed, it's different. We are creating a side effect, and we don't want to do that, all right? So these examples I've given are not pure. Now, how do we go about fixing them? That's what I want to look at really quick. What can we do to fix this problem? Now, taking this first one, what if we declared global num up here with const? So instead of var, we used const. How would that change things? Well, that prevents us from changing that global number using programming. The developer can still go in and change it, but programming wouldn't change it. But it doesn't really solve our problem making it pure, because we're still relying on something that's outside the scope of the function. So let's look at a better approach, and we're going to use closure for that better approach, okay? So let's see, let me go ahead and do it right here. We'll call this new num pure, because this is going to be our pure version. And what I want to do is I want to set up a function here that I can pass in a number. And it's going to set up that number like we had a global number. And it will add that number to any number gets passed in. So really what I'm doing here is I'm going to return a function. So here's the function that we're returning that receives a number as a variable. And then what does that function return? Well, that function returns that number multiplied by the factor or whatever number we set up when we created the function. So we're going to create a function first, and then that's the one we'll use in place of this one up here. And we're able to set up something like a global number, a number that is always static, does not change, by using closure, because we'll pass that number into this, and then this return function will always have access to that number using closure. Okay, so I'm going to call this new num new, And the way we're going to get that function is simply calling new num pure, and I'm going to pass in the number 9. Just like we had a global num up here of 9, I'm going to pass in that number 9. Okay? So now let's save this and take a look at it. And notice the function we're going to be using is new num new. Okay, and we're going to pass in a 5 just like we were doing before. We invoke it, we get 45. If I continue to invoke it, we continue to get 45. And there's no way to change that factor, that number we passed in. We can't change that. It's referencing it through closure. And so that's going to not have side effects, and we're always getting the same value returned when we enter the same value. Okay, one more fix we're going to look at here. And that's we're going to modify this one up here. So I'm going to create a different function for remove last score. I'm going to call it remove last score pure because it's going to be a pure function. And this also is going to receive an array of scores. But then what is it going to do? All right, we're now going to use our spread operator here, our spread syntax here. What we're going to do is we want to create a new array before we pop off the value so that we're not affecting this array here, because that would cause a side effect if we change this array here. So the way we do that, we set up an array, we use our spread operator to get the values from whatever array is passed in, and then we pop off the value like that. Okay? And it's going to return that value that's popped off. Now up here, the reason this caused side effects is because remember, when we passed in this array, even though it's a different variable here, it references the same array. So as soon as we pop off the value, it pops it off of the scores array. Okay, and so we have a side effect there. Here, we're creating a new array. We're using the array that's passed in, creating a new array using our spread operator and putting it inside of square brackets. And then we're popping off a value. All right. So let me comment out this line here. And we'll do the same thing. We're going to use the same variable, let last score. And this time we're going to call the remove last score pure, that function. And we're going to pass in the scores array like that. All right. So save that and we'll take a look. Let's just see what last score is. And we're getting a 60 there. Let's take a look at the scores array, see if we modify that. Nope, we haven't. It still has 4 elements. And there we've made that pure now. By creating a new array and then popping up the value off of that, we've made it pure. All right. So those are 2 pure functions. Those are the most common ways of making things unpure, is by changing a global variable or by changing the argument that's passed in when it's an object. And as we've talked about before, objects in JavaScript, they're referenced. The variable references the actual object. And so we change it one place, we change it someplace else. Now, got a question for you. Can every function be pure? I want you to give that some thought, and we're going to address that very question in the next topic.